So this week is sort of a testing week. You guys have been taking various quizzes throughout the week. That's going to continue. We've got our mock exam due on Tuesday, which means you'll have 4 days to complete it. And so there's 27 multiple choice questions that I've created based off of previous AP exams. It's actually the longest assignment I've ever written as far as time it took to write. So it took me about 30 hours to make it because I was also trying to make all the wrong answers the same way that College Board did. But the good news is I'll be able to give you step-by-step feedback really quickly with that one. So pretty much as soon as you submit, you'll get scoring guides. Okay, so I'm going to quickly go over derivatives of inverse functions. We'll take a look at one for your response, and then we'll be done for today because the homework's a little bit longer. So we're going to be looking at our three pre-calc theorems. That was mean value theorem, intermediate value theorem, and extreme value theorem, and then deriving inverse functions. Focusing on the inverse functions for the lesson. So an inverse function is whenever you change x and y and solve for y. So you just change your input and your output. So normally, if I had a sine function, we could say the sine at pi 6th is 1/2. If I wanted to do the inverse, then I could say the inverse sine of 1/2 would give us our angle, pi 6. So our output and our input change. If I wanted to solve for it, then I could replace whatever my y value is, that's my function of x, and x, so just change them out and then solve for my new inverse function. So now instead of x, I have an inverse. Instead of my y value, I have my new input for my inverse function, and just solve for the inverse. Graphically, I could say that if I was going to draw a line, y equals x, so something like this. My inverse function should be symmetric about that line. So if this is a piece of paper and I folded it about this green line, then this red function would end up overlaying this blue function, right? So that's because I've changed my outputs and inputs. Any questions just on what an inverse function is?
Can we do an example?
Right. So for our example here,
please.
If I want to find the inverse function of 4x squared plus 4.
Yes.
I'm going to change my x and y values. So now my new input is where my output was. And my new output is where my input was. So I was squaring that, plus 4. Okay, so this is x minus 4 divided by 4 would be my inverse function squared. And then take the square root.
And why do I need to find the inverse function?
So let's say our function was velocity. So velocity in terms of time originally. If I wanted to find the opposite,
Yes.
so at what time would I have a specific velocity, then I could use an inverse function instead. So all it does is it changes your output and input. Okay, so where this gets tricky is when we look at derivatives. So I'm really going to quickly prove our formula for this, so which you already know from the formula sheet. But an inverse function by definition changes the output and the input, which means instead of f of x, equals some function. I would change my output and input. So instead of plugging in x as my input, I'm going to get my inverse function, and then my output would be here. Okay, so if I derive this, I'll get f prime at my inverse times the derivative of the inverse should equal 1. Now this derivative of the inverse is what we want to solve for. So I'm going to divide both sides by everything that is not what we want, not the inverse. So that's the derivative at the inverse. The derivative at the inverse. So this will cancel. And I'll be left with the derivative of the inverse is equal to 1 over the derivative of the original function at the x value of the inverse. Okay, so we just got here with chain rule. Here's an example. So our original function was 4x squared plus 1. I wanted to find the derivative of the inverse at x equals 17. So using our formula, the derivative of the inverse is 1 over the derivative of the original function at the inverse. I would have 1 over the derivative of the original function at the output of 17 for my original function.
Okay.
Okay. So I would plug in
How do we get from step 2 to 3?
How do I get from step 2 to 3? So I'm going to solve the inverse first. So if I do, I've got 17 equals 4x squared plus 1. 16 equals 4x squared, therefore 4 equals x squared, or x is 2. So that gives me my derivative of the original function at 2. So if my original function is 4x squared plus 1, my derivative is 8x. So that's 8 times 2, or 16. Okay, here it is again from step 2 to 3. What this step is doing is it's actually solving for the inverse from here. So if I have f of x is equal to 4x squared plus 1, and I swap out my output and input, squared plus 1, and then solve for the inverse, I'll have x minus 1 over 4 underneath the root is equal to the inverse, which is here. Okay, so if I plug in my x value of 17, I would get 17 minus 1 is 16, divided by 4 is 4, under the square root is 2. So my inverse at 17 would be 2. Okay, then I can plug into the formula. So my inverse at 17 is 2. So I'm going to replace this inverse at 17 with just 2, and then take the derivative of the original function. My original function was 4x squared plus 1. Derivative is 8x. Plug in 2 is 16. Okay, any questions on what we did?
No.
Cool. Okay, so I'm gonna look at one free response that uses it. Okay, so I've got this table of my function f and its derivative, g and its derivative, and a bunch of x values. I'm also told there's another function h, which is f of g minus 6. So it's a composite function, means I'm plugging g into f. Okay, the first thing they want us to do is explain why there must be some value for r between 1 and 3 such that h at r is negative 5. So I'm going to get h at 1 and h at 3 and just see if we're passing, if we have to pass through negative 5. Since we know that h of x should be continuous because f and g are both differentiable, so the composite should also be differentiable. Okay, so I've got h at 1 is equal to f of g at 1 minus 6. G at 1 is 2, so this is f at 2 minus 6, so I'm working inside out. F at 2 is 9. So that's 9 minus 6 is positive 3. Okay, are you good on the first step?
Okay. Yeah.
Okay, cool. So I'm going to do the same thing for 3. I'm going to have you kind of help me out with it this time. So this is f of g at 3 minus 6. Okay, so using my table, what's g at 3?
4
4. What's f at 4?
minus 1.
Minus 1. So that's
So
negative
minus 1.
6. Okay, is negative 7. Okay, so we went from h at 1 was positive 3. And h at 3 was negative 7. So what theorem could I use to prove that we have to pass through the point negative 5 at some point between them?
Mean value theorem.
So mean value theorem would prove a slope. Mean value theorem says the derivative at some point must be equal to the average value between 2 points. But I'm just looking at y values. So I've got
So the squeeze theorem.
squeeze theorem squeezes y values between an upper function and a lower function. I don't have a function, I don't have two functions to squeeze this one between. Okay, I've got intermediate value theorem or extreme value theorem left.
I'll remember what's the extreme value theorem.
Okay, so I'll go through both. Intermediate value theorem says as long as our function is continuous,
Okay.
it passes
There's a value.
between all f a and f b at least once on interval ab. As long as our function is continuous, we're going to pass through all the y values between point A and point B. Okay, extreme value theorem says there is at least one maximum and minimum if f of x is continuous. on AB. Okay, mean value theorem says there is a derivative point C on the interval AB such that the derivative is equal to the average slope. If f of x is differentiable on AB. Okay, so mean value theorem is the most complicated one. It has more conditions, so you have to be both continuous and differentiable, whereas all the others just have to be continuous.
Okay.
And then squeeze was squeezing between two functions. So which of these theorems can be used to prove this?
The first one, E.
IVT, so intermediate value theorem.
Yeah.
So
There we
as
go.
h of x is continuous on the interval 1 to 3, and h at 1 is greater than negative 5 is greater than h of 3 by the intermediate value theorem. H at C equals negative 5. For some C, on the interval 1, 3. Okay, any questions on what we did?
No.
Okay, and that is possible to have more than one C. I could bounce between I could bounce around negative 5 as many times as you want. But we have to have at least one in order to get from point A to point B. Okay. Part B. Explain why there must be a value C such that the derivative is equal to negative 5. Okay, here's all our theorems again. Which theorem do you think we're going to use?
The extreme value theorem.
Okay, extreme value theorem says there will be a maximum. I'm looking for a derivative though.
Also for a slope.
Yep.
So the mean value theorem.
Okay, so we're going to use mean value theorem. So that means I need to figure out what the average slope is between 1 and 3. Okay, so my average slope is h of b minus h of a over b minus a.
B minus A.
Okay, so we said h of 3 is negative 7. So that's negative 7 minus h of 1 was 3 over 3 minus 1. Okay, so that's negative 10 over 2, or negative 5 is my average slope. Okay, so therefore, the mean value theorem h prime x is differentiable. Guarantees h prime c equals negative 5 for some c between 1 and 3. Okay, so key point, we found the average slope and the function is differentiable. Any questions here?
No.
Okay.
How do we see if it's differentiable again?
Because we know f and g
That
are differentiable, and h of x is composed of f and g. So because
okay.
h of x depends on f and g are differentiable. This is just f and g in a constant. Then this function should also be differentiable.
Okay.
Okay, then proceed. So if I want to find the derivative of w, where w of x is this integral, what happens if I derive the integral?
If we derive the integral,
Guess we'll do the general form first. If I derive the integral of f of x dx, what will happen?
fb times b prime minus fa times a prime.
Okay, so we're going to do the same thing. So this will be f of g of x times the derivative of our
Times
upper
g
bound,
prime
g prime.
minus f of 1
Oh,
minus
here, f of 1 times derivative of 1.
x
Derivative of
as
1 is 0, so integral of
0.
x is 1. Okay.
0.
Okay, cool. So, f of g of x, if I want to do this at 3, would be f of g at 3 times g prime at 3 minus 0. Okay, so I'm going to go to the table now. What is g at 3 first?
4.
Okay, so this is f of 4 times, what is g prime at 3?
2
2. What is f at 4?
minus 1 negative 1.
Negative 1, so that's negative 1 times 2 or negative 2. Okay, any questions on that one?
No.
Cool. Okay, so last one. If I derive an inverse function, I would get 1 over the derivative of the original at the inverse. Okay, so if g negative 1 is the inverse of g, then I want to write an equation for the line tangent to the graph of y equals the inverse at x equals 2. So by definition of an inverse, at x equals 2, if 2 is my input for the inverse, then that should be my output for the original function. So that means my output for the original here was 2, which means my input for the original was 1. So g at 1 equals 2. Therefore, the inverse of 2 must equal 1 by definition of an inverse. Okay.
Okay.
So then we can plug into our formula. My derivative of the inverse should be equal to, I might run out of room actually, I'm going to move this over. My derivative of the inverse at 2 should be equal to 1 over the derivative of the original function at the inverse of 2 which we said was 1. So that's the derivative of the original function at x equals 1, which was 5. So that's 1 over 5. Okay, so now I've got an input, an output, and a slope. So how can I write the equation of the tangent line?
Y minus B, but B is 2.
Okay, so b
Oh,
is actually 1 in this case, because our y value is the inverse function. So my
yeah,
y value is going to be the output of that function, which is 1. Okay, keep going.
equals to G prime of 1 over 5. Oh, it's just 1 over 5. Or
Just 1 over 5, right? So that's g prime at x, where x is 2, times...
at minus 2.
Perfect. Should be our tangent line. Okay, let's see how we did. So h1 and h3 are 3 and negative 7. We got that. Uses intermediate value theorem. Okay, we cited that. Average slope. Okay, using mean value theorem, we did that too. I don't remember. Let's see. Okay, we did get negative 2 and we did use chain rule. So that's good. G prime, or the inverse at 2 is 1. Inverse at 2 is 1. Okay, we got that. The derivative of the inverse at 2 is 1/5. We got that. And our tangent line, y minus 1 equals 1/5 x minus 2, which I believe we got right. Yeah. Okay, awesome. Any questions on anything?
No, it was clear.
Cool. Well, thank you very much for coming.
And for homework,
So for the homework, I've sent on WeChat and Skype. The homework's a little bit longer this time. It is actually going to count for a test grade this time. There's 27
okay,
multiple choice questions, but you have an extra day to do it. So it's due Tuesday at midnight, which gives
okay,
you the whole weekend, and then if you forget, 2 days next week.
okay. Thank you.
Okay, no problem. And I'll see you next week. Have a good weekend.
Yeah. Bye.
Goodbye.